This is an example of what is sometimes called backward reasoning. It uses the Modus Tollens implication rule. We call the example election. The story is this. An election is coming up. I must endorse either Carol or Peter. If I endorse Carol, she will win. If she wins, taxes will be cut. We cannot cut taxes, therefore I must endorse Peter. We begin by assigning these names to the basic statements. C represents I endorse Carol. P represents I endorse Peter. W represents Carol will win. And X represents taxes are cut. From the story, the premises that we extract are C or P, that is, I must endorse Carol or Peter. C implies W, that is, if I endorse Carol, she will win. W implies X, that is, if she wins, taxes will be cut. And not X, taxes cannot be cut. The conclusion to be drawn is P, that is, I must endorse Peter. The premises of this problem are C or P. C implies W, W implies X, and not X. The conclusion we seek is P. Notice from the first premise that either C or P must be true. If we could show C was false, then we would be done. Thus, an intermediate goal is showing C is false. So, how can we show C is false? We reason this one backwards and see that if X is false, from the final premise, we would obtain W must be false, since W implies X. But then, from the second premise, which is C implies W, we would have C must also be false. Showing C was false was our intermediate goal. If you would like to produce the proof on your own, you should pause this video now. The proof begins with listing the four premises, C or P, C implies W, W implies X, and not X. Now, from lines 3 and 4, we see, using Modus Tollens, that W must be false. Then, from lines 2 and 5, again using Modus Tollens, we see C must be false. Finally, with C being false on line 6 and C or P being true on the first line, P is true using disjunctive syllogism. That was the conclusion we sought. Not only did our discovery of the proof move in a backwards fashion, the actual presentation of the proof also proceeds backwards. When we have a sequence of implications, we can often chain through them in a forward fashion using modus ponens. Sometimes, however, we move backwards using modus tollens. This proof is an example of that approach.